It has been a rough, easy problem. As always, the result will appear right here. As you can see, I had 3 failed attempts. Submit. Here it goes. Thank God, it's accepted. Finally. Oh my God. Well, hello guys. Today we are going to seek some coding puzzles. Let's go to Let Code, one of the best websites for coding problems. They are oriented to coding interviews, but still they have very nice coding puzzles, coding problems. Let's do a warm up first. Let's find a let's look for an easy problem. Easy. How about string matching in an array? So Let's Code is full of coding challenges, coding problems, and puzzles. So it's a great place. Given an array of string words, return all strings in words which is a substring of another word in any order. Wait, what? Given an array of strings called words, return all strings in this array called words, which is substring of another word in any order. Okay, I like this problem. Well, yeah, the definition of a substring is very straightforward. Let's look at it right here. So I guess if let's see, we have a string x, and then we can construct all the superstrings of x just like this. We add characters here, and we can add characters here. So for example, one of such examples will be AAA, BBB, string x, and then some more stuff, CCC, BBB, and so on. So obviously we need a function that detects if a string is a substring of another one. So basically the function isSubstring is actually more challenging than I thought. Okay, so the function isSubstring is actually harder than I thought. So for example, if you have this string AX, AW, and you want to determine if it's a substring of AX, AW. So let's say, so a naive approach will be, okay, so let's say A is the same as A, X is the same as X, A is the same as A, and now W is not the same as X, so let's go back all the way to A, and then let's keep going. We keep going here, so now we say A is the same as A, and W is not the same as X, and now we finished the string, so we didn't find the string. So it's not a substring according to the naive approach. However, you can see that the string is right here, AX, AW, and this is the string right there, AX, AW. So a naive approach of isSubstring is not gonna work. Okay guys, so I just coded here a naive function called isSubstring in this coding challenge. The function isSubstring gets string 1 and string 2 as references. Just like here, it matches the character, and then it advances. If it's the same, it advances. If it's the same, it advances. If it's not the same, I go back all the way to the beginning in the first string, and then I keep going, and then I keep matching. If it's the same, I advance. If it's not the same, I go back to the beginning. This naive function, I'm gonna test it. Let's see if it works right here. Okay, so look at this. ABC is a substring of XX, ABC, XX. That works, okay? So now let's try this one. So ABC is not a substring of XX, AC, XX. Okay, let's try the empty strings. The empty string is a substring of the empty string. So far, so good, right? Right? Well, let's look at the counterexample that I found. There's AXAW and then AXAXAW. So now my naive approach is not gonna work. Look, AXAY is not a substring of AXAXAY, which it is because AXAY is the last part of AXAXAY. So how do we fix this? The problem lies that we go back all the way to the beginning. The first time that we find a non-match, we go back all the way to the beginning, and that's the problem. Let's fix that. So we have to go back all the way to the beginning in string 1, but in string 2 we also have to go back a little bit. So how much do we go? Okay, so I created a rewind a rewind patch that when we are rewinding the pointers, the chars, uh, we rewind them correctly. So here now is detecting AXAY is a substring of AXAXAY. Let's try ABCX is a substring. Okay, so the substring function is working now. So now we have the substring, the is substring function. Now let's time to code the main algorithm. So let's do that. Let's do the brute force approach. Compare each pair once. It's quite a lot of code. It's not that easy. The thing is that I'm not using the string library functions. The string library has a function is substring, and I'm making everything from scratch. The good thing is that my solution should be faster than most of other solutions. So let's see if, first of all, let's see if it is accepted. Let's submit. I hope it's accepted. Let's submit. It's not accepted. Okay, so like I said, I'm struggling a lot with this problem, but okay, so I had to create a hash table that tells me whether, in order to avoid repetitions, I have to create a hash table that tells me if I have already inserted that string. So what I'm going to do here is update that hash table. Okay, so now my crazy idea is working. Whoa, this is crazy, man. This is what happens when you do things from scratch. You don't have I didn't use the functionality of a string, substring, and I created it by myself right here. Okay, so I'm going to submit now. Okay. Wrong answer. I'm doing a repetition again. So the problem lies in my repetition code. So let's try to fix that. Yeah, I think this is going to work now. And I'm paying the price for have chosen the path of building everything from scratch. But you know what? Even though I did suffer a lot, and I don't know if it was a good idea. I don't know if it was a good idea. However, I'm very proud of this algorithm, which is if the algorithm that detects if a string is a substring of another, which we just established that is not as easy as it might seem. Okay, so now let's submit this solution and see if it works. Finally, this is a lot of code, a lot of work. Oh my god, it's not working. I'm still repeating. How is this possible? I guess that we're ready to submit this code. It has been a rough, easy problem. As always, the result will appear right here. As you can see, I had 3 failed attempts. Submit. Here it goes. Thank God, it's accepted. Finally. Oh my God. It's not easy. The thing is that I did everything from scratch, and the function that was most interesting was is substring. Here's the code, and here's the patch. You have to rewind correctly. One final submit, because it took me a lot of time to do this, and very good, very good. Well, let's solve one more problem. Easy problem. These easy problems are not that easy. They're not. You are you are given an array of strings. String problems are very important, are nice. You're given an array of strings called A. That's a nice name to have. My name is A. What's your name? My name is B.2. A moves on a move onto S consists of swapping any two even index characters of S. Any two odd indexes characters of S is also a move onto S. Two strings S and T are special equivalent if, after any number of moves onto S, you can make S equal T. For example, this is a group of strings, and then you have to find how many groups of special equivalent strings there are. So basically, according to what I understand, let's say that you have A, X, B. So you divide the string in odd characters, which is A, Y. So basically, you can do any permutation in these characters. For example, CB, C, CBA, and then I can permute Y, X, and then that will give me C, Y, B, X, and A. And then this string right here, C, Y, B, X, is a special equivalent to, I missed the W, so let's add the W here. So this one is this one is equivalent to this one. Basically, you can permute the characters in even positions as much as you want, and you can permute the characters in odd positions as much as you want. So we need a function that tells us if, first of all, to build that solution. As you can see, easy problems are not as easy. You need a function that tells us whether two strings are spatial equivalent. Let's build that function. So now we have all the elements that we need to solve the problem, this iterator and this char counter structure. Okay, so now that we have all the elements that we need, let's go ahead and do the function R equivalent. Look at the like versus dislike ratio. 306 likes and 1206 dislikes. Personally, I like the problem, but I think it has been quite laborious. I created a jump iterator that iterates through the even or odd characters on a string, and then a char counter, pretty much a hash map or a dictionary or however you want to call it, that counts chars. And then this function normalize that takes a string and it creates if two strings are equivalent, the function normalize creates the same string for both of them. So if one string is equivalent to another in the terms of this problem, which is called a special equivalence, then the normalized function gives the same result with this string and gives the same result with this other string. Why? Pretty much because it sorts the characters. It sorts the even characters and it sorts the odd characters. It creates the iterator, it iterates through the even chars and adds them to the char counter, then iterates to the odd chars and adds them to the odd char counter. Finally, creates the string normalize and it appends all the chars to the even chars and the odd chars order. So basically ordering the string kind of the even chars and the odd chars, ordering them and then putting them together. That string will be the same for all the equivalent strings. So now all I have to do is create a set of strings and then I insert the normalized version of all the strings like so, and then all I have to do is return the size of my set. Okay, it's passing one test case finally. But first I want to tell you, I want to show you something first. Okay, I want to show you this, guys. Look at this. My function. Oh, I didn't want to show you that. That's a compile error. That's not great. Okay, look at this right now. Look at this. Look, pretty much my function normalize transforms, for example, this string ABCD, it transforms it into ACBD. And then any other string that is a special equivalent will get transformed into the same. For example, CDAB gets transformed in the same ACBD, and CBAD gets transformed in ACBD. Also, all these get transformed into the same string. Why? Pretty much because I'm ordering the string, the even characters and the odd characters. So I think this is going to work beautifully. It's a very laborious problem, and I'm ready to submit it. And I'm very ready for this to be over with, and I'm ready to get an acceptance from this problem. And it's accepted, and it's faster. So my algorithm is faster than 100% of C++ submissions, so probably the best ones or on the top. And the memory usage is also super good, it's less than 99.34%. So doing things from scratch do get you very high in speed. It usually gives you better performance, better memory. But these were very laborious problems. So we are done for today. Thank you for watching. Give me a thumbs up if you like it. If you have comments about the video, give me comments because I'm getting started. And there is a long quest, a lifelong quest of solving programming puzzles and coding puzzles and interview problems and all that stuff. And subscribe to the channel. Have a great day, night, or whatever it is. Goodbye.